This video will show you how to get the most out of your Lambda functions and RDS. Straight out of the box, Lambda functions can easily access the internet and other AWS cloud products. But what if you want your Lambda function to access your MySQL database and the internet? Well, the only way to do this is to place your Lambda function in a VPC. And this can be tricky if you don't know how VPCs work, so let's dig in and know your VPC. So this is the diagram that I'm going to be going over in this video. And usually when I create these types of diagrams, I use a tool from draw.io. And these diagrams look like this. They're two-dimensional. And sometimes I have a hard time interpreting these diagrams, so I decided to try a different approach and try a 3D type of diagram instead. So at the very top, these group of items right here represent three components that are running in this private subnet down here. And these components are running in this private subnet down here in US East 1C. And these components are running in this public subnet in US East 1A. And as you can see, these subnets are associated with the main route table, and this subnet is associated with a public route table. So I'm going to be going over all this in detail, and I'm going to log into the AWS Console and talk about how all this stuff works. So let's start at the very bottom and talk about this crazy stuff here. So CIDR notation. So you want to be familiar with CIDR notation. And CIDR notation is basically a way to specify a range of IPs. And it's basically shorthand for saying 10.0.0.0-10.0.0.255. And it's shorter than writing out a whole list of IPs that you want to specify. So in this case, we have 10.0.0.0/24. And what the 24 means is that the first 24 bits are reserved for the network address. So we have 8, 16, 24. And the last 8 bits are used for the host address. So this gives us about roughly 256 IPs. And in this case, 10.0.0.0/16, this is telling us that the first 16 bits are used for the network address and the last 16 bits are used for the host address. And this gives us roughly 65,000 IPs. And in this case here, 10.0.0.0/32, this is telling us that all 32 bits are used for the host address, which really tells us that this range of IPs is just one IP, and this 0.0.0/0, and this is telling us this is just shorthand for all IPs, everything. So in AWS, the largest CIDR block we can have is a /16, and the smallest CIDR block is a /28. And Amazon reserves 3 IPs in a CIDR block, so a /24 will give us actually 251 actual IPs. So when you're just starting out this stuff, when you're learning this stuff, it's probably a good idea just to create your VPC using /16, and all of your subnets. It's a good idea to create using a /24. So if you create all your subnets using a /24, it makes it really easy to determine if an IP is in a CIDR block, because you're going to be asking yourself this question over and over again: is this IP in this CIDR block? And if you use a /24, it's really easy to answer that. Is 10.0.1.10 in 10.0.1.0/24? Yes, you can easily see that. Is 10.0.22 2.22 and 10.0.3.0/24? No, you can easily see that. So if you make everything a /24, it'll make creating your subnets and dealing with security a lot easier. So now that you know about CIDR notation, we can talk about route tables, the thing at the very bottom of that diagram. So here's our main route table. It has 2 routes. We have the 10.0.0.0/16. So this is our largest CIDR block, and this maps to our local VPC. So what this route table is telling us that if any IP that comes in, if any packet that comes in that falls into this CIDR block range, it's going to get mapped to our local VPC. If the packet falls outside of this range, it will go to our default route, which is 0.0.0. This is our default route, so everything will get routed to our NAT gateway. And you can't see it here, but our NAT gateway lives in our public subnet. So our public subnet looks similar to our main route table. It has a 10.0.0.0/16, which maps to everything in our local VPC. And if something doesn't fall into this CIDR block range, it goes to our default route, which is the internet gateway. So this is how we can set up our VPC to have private and public subnets using these two routing tables. So on top of the route tables, we have our subnets. So we have a private subnet, another private subnet, and a public subnet. And these two private subnets are associated to this main route table. And that's called a subnet association. And this public subnet is associated with this public route table. And it's very important. This is how things become public and private. And on a side note, this US1B, this availability zone, is essentially a data center. And this US East 1C is essentially another data center. So this is a data center, this is a data center, this is a data center. So we're looking at 3 subnets and 3 data centers spread out, which is really actually pretty neat. Oops. And on top of the network ACL, on top of the subnets, we have our network ACL layer. And this represents an ordered list of rules. And this network ACL can allow or deny traffic inbound or outbound. And it's very granular, and Amazon calls this the second line of defense. So the good news about network ACLs is that we usually don't have to play with this stuff out of the gate. Usually when you start creating a VPC and you start this stuff, the network ACL is allowed all access to everything, and you don't have to configure much with your network ACL, so we kind of get that for free. And the layer above the network ACL is our security groups. And in security groups, everything is denied by default. And what you do is you allow inbound connections. And once you allow an inbound connection, the outbound connection comes along with it for free. So security groups are said to be stateful with that respect. And Amazon also calls them the first line of defense. So now that we have gone over this, we can see how this works in detail. So I'm going to log into the Amazon console, and I'm going to go over the route tables, the subnets, the network ACL, and the security groups from the bottom up. And you can see this in the console. So we're going to start at the route tables. So here are the route tables. So here's our Lambda, our VPC, our main route table for the Lambda VPC. And it has our routes and our 2 private subnets that are associated with it. And here is our public route table, and we have one subnet associated with it. And here's our internet gateway, and here's our NAT. So these are the 2 routing tables. So that's what that looks like. So let's go up to the subnets. So, I clicked on it. So here is our private subnet, our public subnet, and our other private subnet. So now let's go up another level to our network ACL. So we're allowing all traffic, and we have our 3 subnets associated with our network ACL. And if we go up to the security groups, here are the security groups for our EC2 instance in the private subnet, security group for the EC2 instance in the other private subnet, security group for the EC2 instance in the public subnet, and our security group for RDS running MySQL Aurora, and our security group for the default VPC, which is everything. And these are our three EC2 instances that are running. We have a private, and a public. And our public instance has a public IP, and the two private instances do not have a private IP. So we're going all of this. So basically, to run your Lambda functions in your VPC, your Lambda functions will look like an EC2 instance. So if your EC2 instance has access to the internet, what you do is you simply just run your Lambda function in the same manner as you would an EC2 instance. So you can see that our Lambda functions live here, and a Lambda function must reside in at least 2 subnets. Amazon will not let you run a Lambda function in 1 subnet, so you need at least 2 subnets. So in this example, our Lambda functions are running in 2 private subnets, and these 2 private subnets can get out to the internet, and these 2 private subnets have access to all of the resources in your VPC. So let's test this. So I'm going to run a Lambda function that simply calls Google. And the Lambda function is configured to run in 2 private subnets, as you can see here. And it's using the security group of the default VPC. So if we execute this, we'll see that it returns a bunch of stuff from Google. So our Lambda function can get out to the internet. And this is a Lambda function that calls the MySQL, that calls RDS Aurora database. It's running in the 2 private subnets and using the default security group. So if we execute this, that was quick, it returns a row from a table from our database.